Hi, welcome to the Senior Capstone Project with Siemens Electric. My name is Jacob Parker. My teammates Rayner, Aeriel, Wendy, and I have been working with Siemens Electric's FSP Houston facility for the past 4 months. Now, at that facility, we have chosen to focus on the outdoor shop storage area. Now, the shop brings in parts from turbines and repairs them there, and the storage area is the storage area for a lot of work in process and necessary materials. As you can see, it's very disorganized. The forklift lane that is present here isn't really present because a forklift can't get in there. And we also have a full-size training unit here. That's a turbine that they are using for training new workers. Now, as I said, it's inaccessible. There's a lot of inventory there, and this is leading to a lot of labor costs for maneuvering around the area, as well as a lot of wasted space because the actual inventory and storage method isn't really feasible for the facility. So what we did is we decided to sample some inventory in the area with the help of our Siemens contacts. Now we sampled 30 items, recorded weights, dimensions, and most importantly, frequency of usage, and split up the inventory into 3 categories depending on the frequency. So any item less than a year that's moved every in a matter of months, less than a year, we call fast moving inventory. Anything that's moved every 1 to 5 years is slow moving, and then if it takes longer than 5 years, we consider it non-moving. So from this, we developed our solutions that we would propose, and we developed a new AutoCAD layout, some disposal methods to standardize and help sustain the process, and also some storage and retrieval processes, again, to standardize and help sustain. So getting right into the layout, the principle we focused on was proximity. Some key points here: we've reduced the training area in the blue here to about 50% of its current size. Now that doesn't include moving the full-size training unit. We didn't want to do that because it's not very feasible as far as implementation goes. But we did incorporate a lot of new forklift lanes. As you can see in the white, all of this is now forklift lanes, and these are 16 foot wide, which is up to their specification, and it's what's necessary for moving some of the bigger parts in and out of the area. And with this, we satisfied some of the 6S principles that you see listed there: sort, set in order, sustain, and obviously safety. And this in total has about 14,000 square feet of storage space and about 5,000 square feet of forklift lanes. So I said that we created a layout. We actually created 3 options, each with kind of their own pros and cons, but we scored them based on adjacency of relevant areas, total storage space, lane area, maneuverability ratio, which is the ratio of forklift lane area to total storage area, and there we considered a higher number to be better, and then ease of implementation. And option 2 is the one you saw in the last slide, which is what we chose to be the best. Now, we also created an R simulation to help model some disposal processes. From these, we created 2 disposal processes: a capacity level trigger, which triggers when the area itself reaches about 80% of its storage capacity, and a periodic trigger that recommends disposal of unnecessary parts every 3 years. So these working in tandem, we hope, will help to standardize and sustain some of our solutions long after we're gone. And we also toyed around with the idea of an improved periodic trigger that included a 7-year MACRS depreciation, where if an item has depreciated to a certain amount of its initial value, we recommend disposal of it. And then finally, we also implemented or are recommending implementation of some new storage and retrieval methods. So with this, the first thing is to grid out the area into 6 by 6 foot by 6 foot squares. And this is going to be useful for locating inventory, We also want to employ some pallet racks, some cantilever racks, which they already have, and the cantilever racks will be really useful for things like pipes, beams, longer items that we see there. So the whole new process is revolving around the use of the tooling area's inventory system. And with that comes barcoding for the new items in the area to help keep track of it. And also with the barcodes, we're considering usage of a clipboard or some sort of sheet that is in the area consistently so that workers, when they're actually storing and retrieving the parts, know where to look and where to put them. Again, this is to help sustain and standardize the process. So some recommendations outside of the scope of the project that we thought were useful but we didn't really have time to look into. We're going to recommend looking into purchasing an inventory management system outside of the current tooling one, because while we can use it, it's not necessarily optimal because we're looking at a different type of storage and retrieval process. And we also think it's really important for the company to assess their needs down the line and continually, really. It kind of goes along with the whole continuous improvement idea behind industrial engineering. And that we really want our solution to last, so the best way to do that is to evaluate your needs at every step of the way. And that should never leave the process. Now, as far as implementation goes, we think that we should prepare the inventory first by earmarking everything that can be disposed of in the initial disposal and categorizing all the parts as fast, slow, or non-moving. We also think that removing inventory from the area should be the next step on the first day of implementation. Don't move the full-size training unit though, because that's going to be a whole lot of difficulty and require more labor than is necessary. After all the inventory is removed, mark out the area according to the dimensions we specified, and then finally place back your pallet racks and cantilever racks and all of your inventory in the appropriate areas. So as far as costs goes, you can see that most of the upfront costs are in pallet racks, cantilever racks, barcoding, labor for implementation. These are all really upfront costs that manifest in about $4,500. But the benefits, some tangible benefits, are space savings, really solving the problems that we saw in the problem statement, as well as some intangible benefits like ease of expansion in the future, ability to rent out more space to customers, and customer goodwill for taking their jobs. And as you can see, that's our estimate for the total benefit, and it far outweighs the costs, especially in the long run. As far as results go, based on our estimates, we saved about 32% of space, 25% of inventory costs due to disposal methods, and about 75% of flow and time savings maneuvering around in storage and retrieval in the area. Next steps, we have a meeting with our Siemens contacts next Monday, the 29th, and in that meeting we'll present our deliverables to Siemens, and they will take our files and our data and hopefully implement it in a timely manner. We would also like to thank all of our contacts for helping us out throughout the process. All of our Siemens people, everybody we met with in our visit there, and also our pit professors and anybody else who, I'm sorry if I left you out, has helped us through this process. There's our contact info. If you have any questions, feel free to reach out, and thank you.